Everybody, so yeah, we're moving stuff over out of the ThreeJS service, soon to be renamed to Manager service, and into the Scene service. I'm just going to move over the setup scene today. Probably won't take very long, but basically I'm going to move it, grab it, and then move it in under this constructor, this empty constructor. I don't know if we'll ever need that. So now this scene service doesn't make sense anymore because it's this. And this is this. And then this is this. And those problems all go away. And theoretically, I can just go into the scene service, and wherever I call this setup scene, which I guess I should do a control F on that. Oh, there's only one. It happens during update scene. This dot scene service, setup scene, and just, oh, it's not happy. So I call it directly from the three service from a component. So it looks like this happens in the constructor of the toolbox. So basically, this is code that integrates the component to and the initialization of the component to the ThreeJS. So that probably means that I need a scene service because I don't really want my let's see setup scene. I don't want the components directly talking directly to the or interacting directly with the anything that interacts with the API directly, just as a way to keep everything divided up, so that when we have, so we don't have to sort of understand whenever we're trying to work out with one section of the code, we don't have to have a working understanding of all the different pieces in one place. So here we go. I guess we should just make sure it works. Now, I was kind of playing around with the idea of, I think this is like kind of like probably the most obvious usage of this sort of tool is based on astronomy. And it's kind of, I guess, the scales on astronomy are so weird that, I mean, they're just so enormous and strange that it's hard to like picture them. And I was trying to figure out, okay, how do I represent like the moon uh, in a correct way? And I guess what you have to do is you would have to set up like, okay, so like my camera is sitting at 5 on a Z. So let's move the camera to 0 so it's a little bit easier to um, to just so I'm sitting at 0, which we'll imagine that's Earth, and then I'm looking at the moon, and the moon is let me get Chat GPT up. I've been kind of messing around with this. Uh, let's see, how far is the moon the Earth? So the moon is 384,000 kilometers, or 221,500 miles. So let's just make that around 384. So we're going to say it's 384 times 1,000 away from us. So I'm going to create a mesh, and I'm going to make it, I don't even know. I'm literally just spitballing here. A sphere, and I think it's, well, Oh yeah, it's because I'm sitting at 0, 0, so I'm sitting where the mesh is, and I'm gonna put it uh, at negative 384. So that is the moon. Now it's a radius of 1. Okay, so we're saying that this is 384,000 kilometers. Okay, now let's say how wide is the moon in, I guess we want to know what the diameter, what is the diameter in kilometers. Sometimes they're called kilometers, so we call them that, and sometimes. So it's 300. So how does that work? So it's like 3.5 times 1,000, whereas this is 384. So I don't think that's going to work, right? Because I'm thinking, is diameter? Yeah, diameter is all 2 times the radius. Um, so if I made this 3.4, I guess, I don't know. I guess that is about what the size of the moon might look like. Let's see. The problem is sometimes it looks bigger, and then sometimes it looks smaller, and I don't know if oh, this is the average. Okay, so let's do what is the shortest difference. I'm 356. Okay, so and that was 384. So um, what did I make it? Three. Let me see. Um, so 356. Oh, didn't. I feel like sometimes the moon looks that big to me, but I actually, and I don't know why. Oh, my number locks are off. 356. So I don't know. It's so hard. I know it seems like it's bigger than that sometimes, but um, radius, because that's 3,400, and I don't know how I lost my chat GPT. Um, oh, see, because some of it, because of our range of distance. I forgot about that. We have this in the camera. It sort of, the field of view affects that. And I don't know. Let's try making it like 170. No, that did not help. What if we make it like 10? Could have sworn this. Oh no, okay, so it wasn't the field of view. It must have been the range of observable world that is visible. Okay, so let's make that back to 100. I think it's this aspect ratio. The ratio of the women. Yeah, because. But that's just this thing. Near, far. I don't know. I don't think that's right. Okay, let's see if it can do. What size should I make a sphere on a computer screen to look like the way the moon looks from Earth? Who the heck knows what I'm going to get out of this? Okay, the average angular size. To match the angular size of 0.5 degrees. So it says you can use a field of view setting of 0.52. So like GS2 sphere. Wow, it's giving me some code. Inner width, this looks a lot like material distance from, so it's saying the camera distance from the camera should be 200. And a field of view of 75. So let's give that a shot. See what happens. So field of view of 75. And the distance should be 200. And they're saying that is about what the moon looks like. I don't know. Just don't know. It's like, oh, one thing, well, that just can't even. I was going to say I didn't account for the thickness of the Earth because we're actually sitting on the surface of the Earth. But anyways, yeah, according to ChatGPT, that is what the moon would looks like to our eye on Earth, and I just can't argue with it. The problem is like if you try to just look up a picture of a moon, um, um, you're gonna get, they're gonna zoom in. They're just not gonna be uh, in the sky with stars. So like that, it's probably still zoomed in. As seen from human eye. Search. Yeah, I just, yeah, it's going to be, I guess the math is kind of interesting. But yeah, so according to ChatGPT, this should have got it. I don't know. The field of view, I don't know if that's doing anything though. Maybe we should double check to see if if it's still working. It kind of seems like it might be broken. Um, and yeah, that might be something to do, is double check that the field of view is working. I wonder if I have an error in the console log. This mesh was at a, yeah, okay. Let's see if this does anything. It almost seems like nothing is doing anything. Oh yeah, it doesn't look like any of it is working. Let's see, we'll just look at how that's working. But it doesn't look like the field of view or aspect ratio. Definitely the far. I mean, we're definitely looking at farther than 0.1, so that's definitely not working. We know the positions work, so yeah, it looks like the field of view and aspect ratio are broken in the near and far part of the code is not working properly. And yeah, maybe that has messed up the whole experiment, which I think is probably par for a course when you kind of work on something like this, and then you're like, oh, I'm gonna do like a for real example, and then yeah, you kind of weird things happen. I wonder if orthographic is, yeah, so that's still working. Although when we go, oh, so it does look like once I went back, it did it right. It actually looks like it set it. Let's see. But this might be the problem. Here, let me refresh. Let's go ahead and add the mesh. Make it 200 away. 230 is fine. Go to the camera. I guess that, oh yeah, the width was like, I don't know. Let's see. Let's go ahead and make it a sphere. It's a little easier to deal with. Okay, so now let's go over to the camera. And so there are, oh yeah, because I had also messed with the far and the near. Okay, so the field of view is 70. Which one? What? That is so pretty. Let's see. It said you should have a field of view of 75. But so let's just try 7. Go to orthographic and then back. Do 5. Orthographic and come back. And see, what else did it say? It said make it, I think it said sphere size with a radius of 1. Let's see, distance, okay, so 200. So let's do that. $200, and then I don't think they never do set the, oh, they said the perspective camera was 75. Okay, so and then so let's go back to the camera, set that. Okay, and so that's where we're at, I think. 75. Yeah, so I guess that is what I do think that looks right. And but like if you were looking through a window that was like this size, I think that looks right. Um, I don't know what happens. Like, let's say you were. Let's see. Add mesh. Show edit form. Sphere. And then we were doing. We made it. I can't even remember. Was it 250? 200 exactly. 200. And then radius sphere position is 200. That's what we did, right? That's, oops. Oh, did I make, it should have been negative 200. And it really should be like 195 because the camera's sitting at 195. And then, yeah, this is not right though. Oh, because now we're looking on a wider screen. So, 75, go to orthographic and back. Yeah, because now we're looking at a wider screen. So it's like, this is if we saw this much width, this kind of aspect ratio. So I wonder what happens if I change this to a 1. Orthographic. It just kind of stretched out because of the screen is not quite right. So then I guess if we were to do this, let's see, and then, oops, make this like really narrow and do the same thing. Then it would be bigger, I'm guessing. Add mesh, show edit form, -200. Let's kind of expand it out. And I don't think there's anything else on here. Yeah, camera. Show edit form, field of view ratio, 75. What am I doing wrong? Let's see, orthographic. Oh, it's not a, it's a sphere. And camera. Yeah, I don't know. These are like kind of the things to think about. It's kind of what I would like to do. I'm thinking is, um, I'm thinking, like if I actually put an object that is relatively the same size as the moon, and I put it like relatively the same distance as the moon, shouldn't it look like the moon to me? Um, it seems like that logic. I don't see what's wrong with that. Um, why that wouldn't play out? And I know that logic doesn't always play out in real life the way it does, but it seems like if the width of like the size of the moon, the width of the moon is 200 whatever it is, and then the size of the moon, and then the distance is like relative to the number of miles away or kilometers away. Um, it seems like it should look the same. It's just like, um, yeah, if this is a ball that's, and the problem is this isn't necessarily in any, like, so it's 1 and it's 5 away from us, and now if I make it -5, now it's 10 away from us. Like, what? That's not, is that the same? And then like, yeah, so then like if I say, okay, this is, um, every one of these is a kilometer, then this thing would be like, what was it, 385 kilometers away, times 1,000. So, and then if we say that, we say, well, how wide is the moon? Um, let's see if I remember. What is the diameter? And then, so it's 3.5. Um, so right, and so that definitely does not seem like this. But sometimes the moon does seem tiny like that, especially like if you're looking and at it in the sky. I'm actually just going to pay attention tonight and see if the moon is out. I don't even know if the moon is out, is going to be out tonight, and just see, like, it is kind of like weird because I think even your eyes will zoom in. I guess our eyes actually can zoom a little bit, when we focus on things. If we narrow the amount of, yeah, and actually I remember when I first started this stuff, I was messing around with that because I was like, oh, when your field of view gets smaller, um, then uh, things look bigger, and they actually do. So, anyways, yeah, that was a video, guys. Sorry, I rambled on so much. But anyways, I'm gonna keep on moving code over, set up scene, is basically just the manager's way of, you tell, hey, the manager, you're gonna have to set up the scene, and it sets up the scene. Um, Tomorrow I'll move update scene over. I know like this. I think this is gonna stay. That's gonna stay in here. Yeah, because you would definitely. I don't know. It seems like this setup scene needs to stay in this manager, and then all of this. So really, update scene is literally just going to update the scene items. Um, and then what's really crazy is like none of these items are actually um, ThreeJS stuff. This is all our stuff. So basically, update scene from here will, from this manager, eventually is just going to be calling to the showtime. It won't even call to the ThreeJS, which I guess makes sense, uh, because I think once you update the scene, um, yeah, no, I mean that totally makes sense. Actually, that is a huge thing because there's a renderer, and the renderer is what uh, takes what merges the Showtime logic, Showtime data with the ThreeJS data. Um, and I just, yeah, that makes total sense. And then, so all the manager is going to do is say, hey, okay, I'm updating the ThreeJS data, and then I'm going to send out a signal to all anything that is has subscribed, and then I'm going to call the setup scene uh, functionality, which doesn't do a whole lot. Let's see, setup scene literally just updates the background color in uh, the actual scenes, um, and it does it based on the scene item. And so, yeah, in the future, I guess what'll have to happen is this scene item will have to get passed in. So you're going to give it a scene item, and it's just going to update the background colors. Um, and I guess the fog situation when we get that next. And actually, I think that does make things make a lot more sense. And this is all about just updating the animation stuff. Um, so yeah, I do think that the more I actually tool around with the idea of updating, of separating out the Showtime functionality from the ThreeJS functionality, it makes more sense. Let's see what else there is in the scene service. So there's a lot of uses of, yeah, so when we add a light, um, all this does is update the scene service. So this is the three stuff, and then uh, yeah, and then like there's really nothing, and then this add light. Yeah, so that updates the light service. This publishes it, that, and then this returns the light item. So I don't know exactly. Scene service, scene 0, add 3 light. And the 3 light is is an actual light. And then this is the light item. And I don't know exactly how this light item ends up in the light. Oh, because the light service add light probably does. Oh, okay. The light service add light does both. It adds it into the ThreeJS stuff and um, into our stuff, into the uh, into the Showtime information too. Yeah, and that's just a further further indication that that makes it a lot more complicated than it needs to be. I think the more I dig into this, like I said a second ago, the more I tool around with this, the more separating those two pieces of functionality makes sense. I do. I don't really like the idea that, and I guess this makes more sense. It kind of seems like the manager should be telling the scene service to remove the light, not just removing it directly. Um, but I think that even makes more sense now that the scene service um, is going to be, kind of pared down the amount. It's not going to have to worry about Showtime functionality. So yeah, no, we are definitely in for a massive refactoring. Um, this is kind of one of those moments when you're like working on a proof of concept, and you've been thinking, oh man, yeah, why not just use this proof of concept? And then like something comes along where you're just like, dang, I should have done this so differently, and refactoring this is going to be a lot of work. Um, I'm still like stubbornly holding on to that the idea that I can refactor this code, and it's a lot faster and easier to refactor this code than to rewrite. But I'm starting to get a little bit shook. You know, maybe not. Maybe it is faster to rewrite with the lessons learned, and then like have it baked in from the beginning that the Showtime functionality is completely decoupled and separate, isolated from the ThreeJS functionality. Um, we'll see. Happy coding, everybody. Bye.